What if the strongest evidence of ancient life on Mars has finally been discovered? Welcome back to All About Mars' Surface, the place where Mars reveals secrets that could change humanity forever. Today, we're uncovering shocking new discoveries from the Red Planet. Discoveries involving ancient organic molecules, hidden underground water systems, mysterious mineral structures, and signs that Mars may once have been far more alive than anyone imagined. And before we begin, make sure to subscribe to All About Mars Surface, because the mysteries you're about to see are absolutely unbelievable. Perseverance Rover has now uncovered some of the most fascinating evidence ever found on Mars, strengthening the possibility that microbial life may once have existed on the planet billions of years ago. Scientists recently confirmed that a rock sample collected by the rover contains ancient organic compounds that could be connected to chemical processes related to life itself. These discoveries suggest that if microscopic organisms ever survived on ancient Mars, traces of them may still remain trapped beneath the Martian surface today. The remarkable discovery came from a rock sample drilled by Perseverance inside Jezero crater, a region scientists believe was once home to an enormous lake and river delta billions of years ago. Using its advanced onboard laboratory instruments, the rover heated the rock samples and analyzed gases released from deep inside the stone. After years of careful examination, researchers identified more than 20 complex carbon-based molecules, making this one of the richest collections of organic material ever discovered on the Red Planet. Even more shocking, several of these compounds had never been detected on Mars before. Some molecules contained nitrogen compounds believed to play an important role in the chemistry connected to RNA and DNA, the systems responsible for storing genetic information in living organisms on Earth. Scientists also identified sulfur-rich organic compounds similar to materials commonly discovered inside ancient meteorites. Researchers believe meteorites may have carried important chemical ingredients across the early solar system billions of years ago, potentially spreading the building blocks required for life to emerge on multiple worlds. Although none of these discoveries directly prove that life once existed on Mars, they are considered some of the most important ingredients necessary for life to form. What makes this finding even more incredible is the age of the rocks themselves. Scientists estimate the samples are more than 3.5 billion years old, from a time when Mars had flowing rivers, lakes, rainfall, and a much thicker atmosphere capable of supporting liquid water across the surface. Researchers still cannot confirm whether these molecules formed through biological activity or natural geological reactions. However, the discovery proves that ancient Mars once contained environmental conditions that may have been suitable for microbial organisms. Because Mars has an extremely thin atmosphere and is constantly bombarded by intense cosmic radiation, many scientists believed fragile organic molecules could never survive for billions of years near the surface. Yet somehow, these ancient chemical signatures remained preserved deep inside Martian rocks, hidden from destruction for unimaginable periods of time. Meanwhile, another incredible observation near Mars revealed the gigantic double-ring impact crater known as Huygens crater. Stretching nearly 290 miles across the surface, it remains one of the largest visible impact structures on the planet. Scientists studying high-resolution images noticed multiple colors and strange surface textures caused by dust, sand dunes, exposed bedrock, and ancient erosion patterns spread across the surrounding terrain. Even more importantly, researchers identified branching channels surrounding the crater, strong evidence that massive amounts of water once flowed through this region long ago. Scientists later discovered carbonate minerals along the crater's rim, minerals that usually form only when liquid water remains present for extremely long periods of time. Clay minerals were also detected nearby, and both substances are strongly connected to wet environments capable of supporting microbial chemistry. These findings support the growing theory that Mars once possessed a thicker carbon dioxide atmosphere, stable lakes, underground water reservoirs, and environmental conditions far more Earth-like than the frozen desert we see today. NASA's orbiting spacecraft also discovered additional hidden mineral deposits beneath the surrounding surface layers. Scientists now believe huge carbonate formations may have formed billions of years ago before becoming buried underground. Later asteroid impacts likely exposed these ancient minerals once again, allowing researchers to study Mars' forgotten climate history in extraordinary detail. Perseverance has also begun exploring regions where underground water may have continued flowing beneath the surface long after Mars lost its lakes and rivers. Close-up images captured by the rover revealed strange crisscrossing ridges forming massive patterns known as boxwork structures. Scientists believe these formations developed when underground water traveled through cracks in the rocks, leaving behind minerals that hardened over time like natural cement. Over millions of years, powerful Martian winds slowly eroded softer rock away, exposing giant networks of resistant mineral ridges across the landscape. Researchers are especially fascinated because these unusual boxwork formations appear extremely rare and unlike anything previously studied nearby. As Perseverance continues exploring higher regions and older rock layers, the rover is essentially traveling backward through different chapters of Mars' ancient climate history. Every layer represents a different era from billions of years ago. Scientists are now studying mineral deposits rich in magnesium sulfate, minerals that usually form as water slowly evaporates over long periods of time. This suggests Mars gradually became colder and drier, yet underground water activity may still have continued beneath the surface even after rivers disappeared. In another stunning discovery, researchers identified several craters partially filled with ice-rich material hidden beneath thick layers of Martian dust. Scientists believe these frozen deposits formed during a different climate period when Mars' orbit shifted, allowing snow and ice to accumulate across the mid-latitude regions. But perhaps the most shocking discovery came when scientists noticed fractures and fault lines cutting directly through these frozen layers. This suggests Mars' crust may have continued moving long after the ice formed, meaning the planet may have remained geologically active far more recently than scientists once believed. The discovery raises an even bigger mystery. Deep beneath Mars' cold and silent surface, could underground heat still exist today, driving hidden activity below the planet?